Welcome everyone to Integrated Math 1. We're talking about statistics. More specifically, we're on 9.2, representing data. So what I would like you to do is I would like you to write your first name and your last name at the top right-hand corner and put that period number. So we are going to represent data in different ways today. So the first one we're going to talk about is the dot plot. Now the dot plot looks something like this. It looks like a line, just one x-axis right here, and it's going to have certain numbers right here. So for example, we could have 0, 1, 2, 3. Or it could be like, hey, this is the numbers 4 through 10. Now we're not going to have like a combination of those. For the most part, it's either going to be one or the other. And then we're going to have dots on top. This represents, hey, look, there's 2 zeros on this. Maybe the data has 4 ones. Maybe there's no 2, so then we wouldn't put any of the dots on there. Now, a 3. Let's say that had 4 threes. And if we had a dot plot that had between the 4 and 5, let's say it had a 4, a 6, and a 7, we would put a dot for every instance of that data. Let's go on to the bar graph, or the bar chart, as some people would say. So let's write that down. Bar graph or bar chart. Now, the bar chart is slightly different. It's going to have both the x and the y axis, x being the one on the bottom right here. Now, the difference between the bar chart and the histogram is going to be that this is going to be discrete data. And when we draw our bars, we're going to have representation of these data right here, like number of something. And we're going to have, this is going to be specific things. So for example, this could be number of sports in the fall, number of sports in the winter, number of sports during the summer. And so for each one of these, the data doesn't continue throughout it, so we're not going to connect the bars. And so it's going to be separate instances. And so we're going to want to label as much as possible. So in the bar graph and the histogram we're going to see, we're going to want to label both the x and the y axis. Let's go on and show the histogram. So the histogram is slightly different. Once again, it's still going to have both the x and the y axis right here. And we're still going to have like a description, like number of something. And so this could be like number of students who are 12 years old, number of students who are 13 years old. And so maybe we have an age range. And so for this one, I kind of think the histogram. And so we'd have the data and be explaining what each of these little bins right here are for. And so for this one, they're going to be connected. And this one kind of looks, to me, it kind of looks like a skyline if you're living in a big city with skyscrapers. They scrape the sky. So that's kind of like this. It kind of looks like this. That's a big difference between the bar graph and the histogram right here. All right, so let's jump into the box plot. So some helpful hints for the box plot. Write that in. I should have labeled this a little bit better. So some helpful hints. So we're going to write the data points in order from least to greatest. This is going to help us out. It's kind of like that median we did the other day. So we're going to begin the number line at the lowest data point, and we're going to end it at the greatest data point. So let's write that in. Greatest data point. Now, we're going to have to choose an appropriate scale. What does that mean? Well, are we going to go by ones? Or we're going to have a stack of data points? Well, this basically means we are going to have to determine, are we going to say, hey, the quiz scores are 9, 8, 7, 10, every instance of that. Or we're going to say, hey, who scored between a 40% and a 49%? And then we take whoever scored in there and we number that up. So that's the difference between one or a stack of data points. So write this in, if appropriate. And so this would be like very important if we're doing real world scenarios right here. We're going to label the number line and create a title for the dot plot. All right, let's go on. So let's actually do 2 examples of the dot plot. Follow with me, guys, in 3, 2, 1. Let's go. So example 1, make a dot plot. So first thing we're going to do is we can start our line, but we have to understand that we're not going to be doing anything until we figure out what is our data. So I'm going to pause this right now, and I'm going to put our data in order from least to greatest. So let's go on. All right, guys. So we've now put our numbers in order. I have 2 7s, I have 4 8s, and then I have 9s and 10s. Well, looks like I can just, for an appropriate scale, I'm going to start at 7. I'm going to go to 10. And I have 8 and 9 in between. 8 and 9. It looks like there's no missing numbers in between. But if there was, let's say if I was missing, there was no 8s, I would still put it so I could show off and say, hey, look, this, I'm showing you that I don't have any data for the number 8. So now what we're going to do is we're going to put our dots. Now we're going to do that operation called, that starts with the letter C. We're going to count. All right, so here we go. We have 1, 2, 4 7s. 8, so it looks like there's 4, so I'm going to put 1, 2, 3, 4. 9s, 1, 2, 3, 4, 5, 6, 7, 8. I have 8. 1, 2, 3, 4, 5, 6, 7, 8. And finally for 10s, I have 5. 1, 2, 3, 4, 5. So let's talk about this real fast. Now, I love using graphs for this because then I could put one circle for one box. Now, when it's a white paper like this, it's a little bit harder to visualize. Like, for example, there's twice as many 9s as 4s, but I didn't draw it like that. So it skews our data and it skews visually what we're going for, because this is literally a visual media to show off and be like, hey, look, here's our data. We can see which ones are more, which was the mode, and we can see, all right, there's a certain pattern to this. There's a certain shape, and we're going to be talking about that in the next coming lessons about what is the shape. All right, let's go on to what if we're going to stack the data. So make a scaled number line dot plot. So write that in. So football. So it looks like we have a bunch of data right here. So I'm going to pause this right now, and I'm going to put the data out for you to see in just 2 seconds. All right, everyone. So I've actually put the data in numerical order, and I put them in certain bins. Now, looking at it, I've done it by putting the numbers into groups of 30. So why don't we draw our shape out, our line out, and go from there. So I'm going to draw my line. Now I'm going to look, I have 1, 2, 3, 4, 5. And now I'm going to tell you what are my categories. So my categories are actually going to be 30 from, starting with 180. So this is going to be from 180 to 209. And then we're going to have from 210 through 239, followed by 240 through 269, 270 through 299, And finally, we're going to have 300 through 329. And so here is my dot plot number line right here. Looking at this, now I'm just going to place how many of each between each of these do I have. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The next one I have 4 of them. So I'm going to put 1, 2, 3, 4. Followed by 1, 2, 3, 4, 5, 6, 7, 8. All right, while I'm putting 8 dots, what strategy did I use? I used that C word. What is that C word? It's counting. All right, let's go on. 295, I have 1. And 305 and 310 gives me 2 right here. So looking at this, what we would notice is if we used like less numbers, it would stretch out. It wouldn't be as tall. But since we're using like 240 through 269, it makes it taller than what it would normally be. So if we used smaller stacks, like maybe bunches of 10, it would stretch our data horizontally instead of vertically. All right, guys, we're done with box plots. Let's go to histograms and bar graphs. So, bar graphs and histograms. Here's the visual representation right here. We have the bar graphs right here, where we have discrete data, where they don't connect at all. And then we have histograms, where they do in fact connect. You do go from 65 to 70 to 75 to 80 years old. There is a connection between all that. So let's go over some ideas of what they share and what they have in difference. So we're going to compare and contrast bar graphs and histograms. So something that they both share, they're both visual graphical displays of data. So let's write that down. Graphical displays of data. Now they're both bar graphs. They both have bars. So maybe instead of both, I could just, because this is the both part right here, I can just write have bars. And that's the visual representation. How far up? Next, we have the idea that we have the X and Y axis. So we have X and Y values. X values are going to be the specific categories. And the Y values are going to be, for the most part, are going to be represented by numbers. Like how much of this? Like this is going to be 10 speakers. This is going to be $10 million, that sort of thing. Now, bar graphs are going to be separate. So let's write that in, separate. They're also going to be discrete. So they're not connected. Histograms are going to be continuous. They connect. There's space in between the bars. No space. No spaces between the bars for this. So that's a little bit of information about our differences and similarities of bar graphs and histograms. Now let's go over some helpful hints that bar graphs and histograms could have. First, we're going to determine whether the data should be represented by a bar graph or a histogram. So which one is it going to be? Does that mean we're going to have discrete or continuous information? We're also going to have to determine appropriate categories or bins and tally the data. So make sure it's scaled. Next up, we're going to draw bars to represent each category or bin. Finally, we're going to label the axes. If appropriate, include a title for the graph. And this is very important if we're going to be using real-world situations, real-world scenarios, so that we can understand it, look at it, and be able to talk about it, communicate. All right, let's go on to the actual examples. So, determine an appropriate graph for this discrete data. Looking at this, we know it's discrete because each of these seasons are specific. So in a survey, students were asked to name their favorite season. The results are shown in the table at the right. Make a graph to display the data. So we can display the data with not a histogram, because this is going to be discrete data. Each one of these has specific discrete data. So for example, I'm going to write spring right here. Next up, we're going to write summer. We're going to write fall. We're going to write winter. Now, we are going to have to change these right here. So I'm going to make my y-axis here. I'm going to separate a little bit. I'm going to put some appropriate scaling for this. So hold it up with me. So let's explain this. I myself would probably want to use a more represented, rather than 10s right here, I'd probably want to do maybe 5s or maybe 1s if I had enough space. But seeing that we only have this space right here, I'm going to put it by 10s. So looking at this, it says spring is 15. So I'm going to go halfway in between 10 and 20. I'm going to put my bar right there. Now, some people like to shade it in a different color so that we see a good pop in our graph. So let's do summer. Summer is 38. So we're going to go almost all the way to 48. And we're going to draw our bar. So I'm going to let's put summer. Let's put maybe sun yellow right there. So you can see that we have not connected because this is discrete data. It's not a continuous data right here. Fall is 11, so we're going to go a little bit above 10, so right about there. I'm going to put red. Maybe the leaves are changing colors in the fall right there. And last but not least, we have winter, except in fact the winter sports are not as much as everyone else. So this gives us a visualization. We can see, all right, look, there's a lot more summer sports than spring or fall. And hey, look, winter right here is the least. And so just looking at this, we can see a visual representation, understand right away, hey, which one's more, which one's less? Let's make a discussion about this. Probably, if we see this, we'd probably plan for more summer sports. We'd probably hire more people to help out during the summer or creating more summer sports for students to play. All right, let's go on to example 4. So this right here is for continuous data. Now, test scores. The scores earned by students on a test are shown in the table. Make a graph to display the data. So looking at this, we're simplifying for time right here. But if they gave us this data, we'd probably want to make our own data like this and be able to create our own stacks, our own bins of information right here. So just looking at this, it looks like, hey, look, this would be continuous data right here. We would want to connect it. So making our graph right here, we understand, hey, it goes up to 10. So at this point, I'd be like, hey, let's do, maybe we do 2s. So I'd say, hey, that's 2, 4, 6, 8, 10. And so this is our number of tests. And this is going to be our test scores right here. I think we forgot to label our X and Y categories on the problem above. Not too big of a deal, but it's very important to label. So I'm gonna create a break in the chart right here, and we're gonna start at 61 to 70, and then we're gonna go to, so let's write this in. So 61 to 71 is this much. Now we don't know anything below it, so I'm going to leave this blank right here. Next up is 71 to 80, and it looks like it's going to be 5. It's going to go halfway in between and connect it. 81 to 90 is going to be 10, so right there. If I had the graph, and I probably should have made this on graph paper, that would be right there, 81 to 90. And finally, 91 to 100 is 7. So right there and there. There's our histogram. Now this data is continuous because it goes from 61 all the way to 100. This is probably in percent. And looking at it, yeah, would this data would it continue from 61 all the way to 100? Yes. And so that's why this is like this. It's not categories. We could make the argument, but in this case, we're going to have this data be continuous. All right, guys. We're going to stop at the right in here, and I hope you guys have a wonderful day. Don't forget to do your work, and I want you to make sure that you have a wonderful weekend. Bye, everybody.